Yeah. Welcome to the week of 518 Math on the Fritz with Mr. Fitz. And what you're going to see when you look at these problems is there's an or problem or an and problem. Those are the two types of problems. If we start with an or problem, it just means that our graph is going to go away from each other at the bottom. It wouldn't make sense if they were going together. If I said you need to be older than 13 or older than 18 to do something, older than 18 is a subset of older than 13, so it's redundant. It wouldn't make sense. So usually or is going to go away from each other in different directions. So here we are. Solve this problem just like I would any other problem. Add 5 because that's the inverse. Divide by 7 because division undoes multiplication. There we go. Harmless. Already to an answer of greater than or equal to 10. But if I come over to this problem and I do the same steps, I add 2 because that undoes a negative. I get the infamous 0. But the problem's not done. You can't just say the answer is 0 because we have to finish the problem. Divide by -3, and it causes our inequality to flip because I divided by a negative. So see, it was really important that we did that last step so that we could get that inequality flip. Dividing by a negative always flips the inequality. Now we see from the graph, this starts at 0, closed, and goes left. This starts at 10, is closed, and goes right. We can see that they are actually going away from each other, so the or condition makes sense. So that was our first step. Our first step was to look at an or condition. Now, if I then change that problem to an and condition, it's going to look a little different. We don't write and exactly the same way we write or. Instead, we're going to do what I call the between format. So if I were doing a between format, it would look like this. I would take that problem and I would say negative 24 is less than or equal to 5x minus 4, which is less than or equal to, let's put a number like 12. I don't like 12. Let's do a number like 26. All right, here's our starting problem. Now, there's no word here. It's assumed to be an and problem because I've got two different inequality signs in the same statement. So I would read this as negative 24 is less than or equal to 5x minus 4, which is less than or equal to 26. Now I'm ready to solve like I always do. Adding 4 would get rid of the minus 4 that's stuck on the x. But I've got 3 locations. I have a left, a center, and a right. In order to keep this thing maintained, I've got to do this plus 4 in all 3 places. Once on the left, once in the center, once on the right. Once I've done that, I'm closer to having x by itself. Now I'm only one step away. To get rid of this 5, I see it's a multiplication. I'll use division, but I've got to do division in all 3 places. Keep it nice and balanced. Negative 4, x, 6. Now this is the perfect setup because x is by itself in the middle. Now I'm going to read this in a different way. X is from negative 4 to 6. So when I make my graph, here's negative 4, here's 6. This format tells me what the 2 boundaries are. The 2 boundaries for this problem are negative 4 on the low end and 6 on the high end. So I would know I can fall anywhere from negative 4 to 6 and still meet the requirements of this condition. And we don't have to do a test point, but if I chose x to be 0, then negative 24 would be less than or equal to negative 4. That's true. Negative 24 is less than negative 4. But negative 4 is less than or equal to 26. That's true as well. A negative is less than a positive. So I like it. This is the way the answer would look on a graph. This is how I do my work to get to that point. All right, good luck with your assignment this week.